Psychrometric chart is important. Psychrometric chart is important because we often need to study the complex processes. Complex processes that in air conditioning it may involve two or more than two processes to achieve the desired condition. In this condition, it becomes very easy to represent those conditions and those processes into the psychrometric chart. So how psychrometric chart is useful for us? Because any state or any point can be easily represented by two intensive properties. That is, if we have two intensive properties known for atmospheric air, we can easily mark that point into the psychrometric chart. Further, when we determine any point in the psychrometric chart, then from that point starting, we can obtain the psychrometric process happening. Let's have a quick look at psychrometric chart, that how it looks. So there are two axes basically here, and the working range has been taken as minus 10 to 55 degrees centigrade, and in this working range of minus 10 degrees centigrade to 55 degrees centigrade, air vapor water mixture both are treated as ideal gas. Already I have told in the one lecture this thing. Now the x-axis is represented by the dry bulb temperature. So you can easily see that the dry bulb temperature is increasing in this direction from minus 10 degrees centigrade to 55 degrees centigrade. So subsequently minus 5, 0, 5, 10, 15 and up to 55 the range is there. The y-axis is being represented by the absolute humidity. And it is represented by omega. So since the quantity is very small, therefore as I told, unit of this is grams per kg of dry air. Since in any air water vapor mixture the quantity of dry air remains fixed, therefore the amount how much omega is present is represented in terms of the per kg of dry air. Therefore, if 1 kg is dry air, then total weight of air will be given by 1 plus omega. So this is the basic inference from this. So x-axis will represent the dry bulb temperature, y-axis will represent the absolute humidity. So absolute humidity will be represented by grams of water per kg of dry air. Now the next comes the horizontal lines. So horizontal lines or slanting lines. So the slanting lines towards the right, these lines wet bulb temperature line. So these lines represent the constant wet bulb temperature line. So this is 20 degrees centigrade, this is 25, this is 30. Now if we vertically draw from this chart, so this will fall into the dry temperature line, and these lines will be represent the temperature at respective states. Further, you can easily determine the, now we have identified the wet bulb temperature line, we have determined the dry bulb temperature line. Now next comes the dew point temperature lines. So what are the dew point temperature lines? So dew point temperature line is the horizontal line. So suppose this is 25, then we know if we draw this horizontally for a given absolute humidity condition, then at the point of saturation where it cuts, this will determine the dew point temperature. So this is 15 will be, or slight less, 14 will be the dew point temperature corresponding to this 10 grams of per kg of dry air. So, but in this case, we need to discuss, if we want to determine any property, then we need two independent property. In this case, dew point temperature and absolute humidity do not differentiate. These are not two independent, because dew point temperature, dew point temperature determines how much the water vapor, till the saturation is reached, till the condensation not begins, it is at the constant pressure. So if pressure is constant, then we know that omega 0.6222 PV upon, it will be given by the P minus PV. Therefore, if PV remains constant, that is omega will remain constant. So omega keeping remain constant, the line where the saturation point cuts, this is called as the dew point temperature line. Now, from this we can clearly bring out effective constant lines where these are cutting will determine the dew point temperature. So now we have identified dew point temperature, wet bulb temperature, and dew point dry bulb temperature. Now the topmost line in this, you see very clearly, is the saturation line. The curved line represents the saturation line. For any saturation line, dry bulb temperature, dew point temperature, and wet bulb temperature will be the same. So this is the saturation curve. As we know, saturation curve means that the tendency of atmospheric air to absorb the additional moisture now is saturated. Therefore, this is the 100% RH line, which is clearly visible from here, that this is the 100% RH line. Now, parallel to this line, you can easily visualize the other lines, such as this is the line of 90% RH, this is 80% RH, this is 70% RH, and so on. So gradually, you can see that as the temperature is increasing, the relative humidity at some point decreases, because as the temperature increases, the ability of atmospheric air to absorb the moisture increases. So this is the one thing that we need to emphasize. Now, one more thing from the psychrometric chart which can be inferred is the constant volume line. So the lines generally are in such a manner. So the lines which are more steep than constant web temperature lines represents the constant volume lines. Further, one more thing is this: since The constant weld temperature lines are these slanting lines, and we have seen the definition of wet bulb temperature, that if adiabatic saturation of water takes place, then this is the ultimately the state received is called as the wet bulb temperature, and the constant enthalpy lines in this case generally coincides with the constant wet bulb temperature. So we have discussed in detail the all the parameters. Now let us summarize the psychrometric chart. So let us first draw a psychrometric chart. So in the x-axis, this is the dry. So this is the dry bulb temperature. In the y-axis, this is the absolute humidity, grams per kg of dry air. Now, parallel to this curve, there are the 100% saturation line. This can be 90% RH, and this can be so on 80, 70, and so on. Now, the next comes the constant wet bulb temperature lines. So in this, H will remain constant, and these lines are also, these are temperature line. These are the constant wet bulb temperature lines. Now next is the constant volume line. So these lines are basically much steeper as compared to constant enthalpy lines. So these are the specific volume constant lines. Now next comes the constant dew point temperature lines. So these horizontal lines represent the constant. So from here we will get the corresponding dew point temperature with respect to the given omega value. So this is all about the psychrometric chart. Now if we understand the psychrometric chart, then it's very easy to find out the psychrometric processes in any direction. So we will discuss about the psychrometric process in the next lecture, what happens in psychrometric process and how the psychrometric processes are useful in air conditioning.